The goal of this example is to graph a quadratic function given in standard form by finding key features of the graph. So we're going to find the y-intercept, the x-intercepts, and vertex, and sketch the graph of g of x in this case. And we have g of x equal to negative x squared plus 6x minus 8. Okay, so the first thing up, we want to find the y-intercept. That is the easiest thing to find, right? So any y-intercept is going to have an x value of 0, right? So we're going to find g of 0, which is negative 8, right? We can plug in 0, but we can see once we do that, of course, that we're going to end up with negative 8, right? Okay, so the y-intercept is 0, negative 8. Now, when we find the x-intercepts, we're letting the output be 0, right? So we're letting g of x be 0 and solving that quadratic equation, right? 0 equal to negative x squared plus 6x minus 8. Now, I have a negative on the outside. You can multiply both sides by negative 1 if you want. You can factor the negative out. However you want to go about that. I just like to have my leading coefficient be positive. So if I factor the negative out, well, I'll be left with negative times the quantity x squared minus 6x plus 8. All right, now I need factors of 8 that add to negative 6. So negative 4 and negative 2 will do it, right? Negative 4 times negative 2 is positive 8. Negative 4 minus 2 is negative 6. That is what that gives us in the middle. Okay, so now I know that either x minus 4 is equal to 0 or x minus 2 is equal to 0. And I want to solve both of those, right? So I'm going to add 4 to both sides here. 0 plus 4. And then over here, x minus 2 plus 2 equal to 0 plus 2. All right, so I'm going to have x equal to 4 or x equal to 2, right? So that means that the x-intercepts are 4, 0 and 2, 0, right? Okay, and then the question of what is the vertex, right? Okay, so let's work on the vertex form over here. So I'm going to have g of x equal to negative. I'm going to factor a negative out just from the first two terms, right? Because that leading coefficient has to be positive. And then I'm going to complete the square. 6 divided by 2. Negative times the quantity x squared minus 6x. Now, to complete the square, I have to take 6, divide it by 2, which is 3, and square it, which is 9. Okay, remember, you got to keep it balanced, right? So add and subtract. Okay, so I'm going to have, if I factor that trinomial, x minus 3 quantity squared, right? Because I have a minus 6 in the middle, so x minus 3 squared, minus 9, right? Minus 8. Don't forget about that minus 8. And then distribute the negative through. So I'll have negative times x minus 3 quantity squared plus 9 minus 8. Okay, so negative x minus 3 squared plus 1. Okay, so the vertex is 3, 1. All right, so I'm going to use these key features to graph this. So let's start with the vertex. I'm going to have 3, 1 right here. The x-intercepts are 4, 0, and 2, 0. This is making good sense so far, right? And negative 8 is the y-intercept. Okay, so here's the deal. You've got what we call the axis of symmetry that runs right through the vertex, right? So these x-intercepts, you notice they're within 1 unit. They're exactly 1 unit on either side of that axis of symmetry. So this y-intercept down here at negative 8 is 3 units away from the axis of symmetry that runs through that vertex. So if I move 1, 2, 3 units on the other side, I can get another point. Yeah? Okay, so you can use that axis of symmetry if you have the y-intercept to find essentially a fifth point on the graph. Okay, so here we go. I'm going to graph that. Very nice. Okay, so in connecting the dots there, we have the parabola that we're looking for. I also encourage you to go to Desmos and check your work as you're doing some of these problems. Make sure that your vertex and intercepts are in the places that they should be.